Hey, sixth grade Success Center students. Glad to see you back. Wanted to remind you before we begin that you're going to need your packet that was sent out a long time ago, and we're going to be working on one of the pages today. But I wanted to remind you that we don't do anything without thinking through. Okay, so remember we'll be using our cube strategies today. Now, we're going to be working on page 85, so I'm going to circle that up for us, page 85. Okay, and we're going to start real quick. Last week, I'm going to go back to last week, we did a lot of things with rates and ratios. And so that's what we'll be working on again this week. So after we've worked this week on rates and ratios, you should be able to tackle that on the study island. That's something else that I've noticed, that we have some people who aren't going to study island. You did it like 2 or 3 weeks ago, but then you haven't gone back anymore. Please go back and visit study island, and especially after we've taken 2 weeks of practice here on rates and ratios, I think it would be time for you to try that on study island. Okay, so I want to remind you about how we have solved these. We've used the box. Okay, so I'm going to go back, show you that we draw a box, and a lot of times that box can help us remember how we solve the problem. It gives us a way to think through in an organized way. All right, so let's go ahead and we're just going to dig right into number 1 on page 85. It says, of 100 students surveyed, 25 said they would vote for Jen for class president. If 2,000 students voted in the school's election, about how many votes should Jen receive? Okay, and so that's helping us to think through. And let me grab a skinnier marker here. Some of the things that we need to think through are circling the numbers. So let's come over here. So we have 100 students were surveyed, and a survey is like a vote. Okay, 25 said they would vote for Jen. Okay, so Jen, out of 100 students, she had 25 votes. Now, what if that 100 were turned into 2,000 students who voted or were surveyed? About how many votes should Jen receive? So we want to know about how many votes should Jen receive. So what I'd like us to do is think about how we would set that up. Well, if I were to draw my box like I'd done before, split it up here. And so at first we have a part and then a whole. And then we have a whole, but we want to find a part. Doesn't matter where you put it on here, but I'm going to put my part on top and my whole underneath. Doesn't matter. This will still be solved okay, even if you put the W on top and the P on the bottom. Okay? You just have to remember to put your numbers in the correct places then. So if I'm going to go with my first set of information, we had 25 out of a total, that's where the whole would go, 25 out of 100. Now, we don't know. This is what we're trying to find. So that's where we'll put our X, our unknown. But we do know the total amount of students that we want to figure it for, and that would be 2,000. Okay. Do you remember how to solve this type of problem? I'm going to pick up another color. You take the things that are across from each other and you would multiply them and divide them by what's left over. So we would do 2,000 times 25. Remember last week what we talked about? An easy way to multiply if you have a lot of zeros. We could consider this just a 2. What is 2 times 25? It's 50. But we have 3 zeros behind that 2. So that means I need to put my 3 zeros behind that 50. I take the leftover piece here, and it's the item that I'm going to divide by. Do you remember how to divide by things that have lots of zeros? I can think of it like this, okay? I want to take the 2 zeros off of here. Whatever I do to this side, I can also do to this side. So I don't have to look at those zeros anymore. I don't have to look at these zeros anymore. And if I were to say, I just have a 500, 500 divided by 1 is 500. That's just one way to solve this problem, and it's solving it with the box, our think box, the box that helps us to organize how we would solve this problem. And yes, I know, I solved this whole entire problem for you, but we have 4 more that we can do together, okay? So, let's look at number 2 on page 85. I'll read it to you. The decorating committee for a school banquet decides to put flower arrangements on each table. Each arrangement will have 3 white carnations and 5 yellow carnations. The committee will need 60 white carnations. What is the total number of white and yellow carnations the committee will need? We're not going to do any work until we've thought this through, okay? So we know that each arrangement, each in this case is going to be a 1. So 1 arrangement will have 3 white and 5 yellow, and carnations are just a flower. So 3 white flowers, 5 yellow flowers. The committee will need 60 white flowers. Okay. What is the total? So we need a total number of white and yellow carnations the committee will need. I want you to take the information that we've thought through, pause the video, solve, come back when you're done, and we'll talk about the answer. See you when you get done. Okay, did you get that solved? Let's look and see how we would solve that together now, okay? I've set up my box, my think box. There's nothing magic about this. It's just a way to organize your thoughts. And I labeled it with W and Y, white and yellow. My white flowers are 3 for every 5 yellow. They had to buy 60 white. We are trying to find the yellow, okay? It's because it says the committee will need 60 white carnations, okay? So if we have to find the total number of things in the end, which I've set up right here, I have my 60, but I don't know what the yellow is yet. So this is a really solid 2-step problem here, maybe 3 steps, depending on how many steps we put inside here, okay? So let's solve and see how many yellow, so we can plug it in down here, find our total, and find our final answer, okay? So I'm going to take my things that are across from each other, okay, and I'm going to multiply those together. And 5 times 60, or I can hold off on that 0 for a second. 5 times 6 is 30. Okay, so I'm going to write that up here. But I have this other 0 here, so I'm going to need to place that there now. Divided by 3. So what would 300 divided by 3 be? Well, 3 will go into 3 once. We go through our steps here. Okay, there's a 0. We would do a bring down. Well, 3 will go into 0 0 times. We'd have another bring down after we did that subtracting. 3 would go into that 0 0 times. And look, I can even check my math. 100 times 3, does that equal 300? Yes. Okay. So now I know I'm going to need 300 yellow. I mean, not 300, for heaven's sake. I was talking too fast. Not 300. I'm going to need 100 yellow. So I put those down. I find my total that we talked about here, and that's 160. But I do want you to take notice here. If you had not read through to the very bottom of the question here, and it asks for white and yellow's total, notice that they do have the wrong answer that comes up with your partial solution to this problem. They do have the number 100 here. So if you're not careful, yes, you could have been tricked into circling B. B is not the answer if that's what you chose, but now do you see if you chose B, you just didn't solve to the end of the problem. All right, now let's look at number 3. Allie ran 5 miles in 36 minutes. Sammy ran 6 miles. If Allie ran at a faster rate than Sammy, in how many minutes could Sammy have run 6 miles? Don't panic. All we do is come back and we think through it, okay? That means Allie ran 5 miles in 36 minutes. That's 5 miles per 36 minutes. Sammy ran 6, okay? So in that amount of time, Sammy ran 6, right? Okay. If Allie ran at a faster rate than Sammy, how many minutes could Sammy, oh, no, he doesn't run in 36 miles. That's what we're trying to find. I mean, in 36 minutes. We're trying to find how many minutes. So how many minutes could Sammy have run 6 miles? So we have Sammy at that 6 again, okay? So what I want you to do is I want you to think about how are we going to solve this problem, okay? Think about using the box, setting things up in the box. This one's a little different than the ones that we've been using, okay? But not too terribly different. Pause the video, see if you can get that set up, and see if you can figure out how this is solved, okay? All right, this was a very tricky one, so if you had a problem with it, don't feel bad. It was a very tricky problem. So let me change my pen color real quick, and I'll show you how we would solve through this. Well, first of all, we knew that Allie ran 36 minutes and made it 5 miles. So I set up my box. So if she just ran 1 mile, how many minutes would that take? Well, I circled up my diagonal things, found the one left over, and then I divide 36 times 1 divided by 5. So 36 divided by 5. I went ahead and did that math. It was real easy. I got a decimal number here. So I did have to do a little bit of decimal number work. So I had a 7.2. So in this box, it would have been 7.2 minutes. Now, we need to find how many minutes could Sammy have run 6 miles. Well, the way that we do that, and we know that Allie can run at a faster rate. So let's have Allie run 6 miles. Okay, how many minutes would it take her to run 6 miles? Because we know that this represents 1 minute. Okay, whoops, 1 minute is what that's supposed to be. And if I multiply this, 6 times 2 is 12. Okay, 6 times 7 is 42, 43. and then I have to put in my decimals, so there's 1 decimal place. Okay. Well, it would take her 43.2 minutes to run 6 miles. So Sammy could not have run 6 miles in 30 minutes. He runs slower than Allie. He could not have run it in 36 minutes. And look, she can't even run it in 40 minutes. It takes her longer than that. So he could have run it in 48 minutes. And that's how you would solve this problem. I know it was a little hard, but maybe it helped to see how that problem was done. Okay, we're going to go on to number 4. Number 4 says, Kevin plays quarterback on his football team. The table below shows the number of passes he threw and the number of passes he completed in 4 games. So we look here. Whoops, I didn't mean to make that all disappear. We look here, and he doesn't have a rate that is the same. Like in this game, he completed 15 out of 25, 10 out of 15, 15 out of 30, 12 out of 20. But our question asks this: in which game did Kevin complete passes at the highest rate? Now, in order to do this, we have to find the rate for each one of these things. Now, to find a rate, watch what I'm going to do, okay? For number 1, I'll show you. I take passes completed divided by passes thrown. Okay, so that would take the number he whoops, let me try that again. Whoops. Let's go back here. Okay, so we take the number he completed, but he threw 25 of them. So his rate was 15 out of 25, but we don't really know what that is. I mean, this was 10 out of 15, 15 out of 30, 12 out of 20, but what we need some decimal numbers to help us know what that could be, okay? So if I take this, each time I do this, I need to do the numerator divided by the denominator for every one of these, and I want to see the one that is the highest. So shut off the video, do the math, come back and see if you got the same game that I got for the highest rate of his completed passes. So do that now. All right, now there were 4 problems to solve on here, but they weren't too terribly hard. So you would take passes completed divided by passes thrown, and I did that for game 1, game 2, game 3, and game 4. I placed them over here on the chart, and if you'll notice, game 2 had the highest rate because I was looking for the rate that was the highest, okay? And it had a repeating decimal. So let's go on to the very last one here. Number 5. Charles wants to visit his family 1,400 miles away. His car can travel about 25 miles on 1 gallon of gas. It takes 15 gallons of gas to fill the tank, which is the best prediction of the number of full tanks of gas it will take Charles to travel that distance. Okay, let's circle up what we know. That he has 1,400 miles to travel because he wants to visit that family or his family. His car can travel 25 miles on 1 gallon of gas, and it takes 15 gallons of gas to fill his tank. I'm going to underline all of that, to fill his tank. Now that's a lot of information. Let's see if we can figure out what the question is asking. Which is the best prediction of the number of full tanks of gas it will take Charles to travel that distance. Okay, so think through it. You know how many miles he has to travel, how far he can get on 1 gallon of gas, and he can have 15 gallons at a time in his tank. Try to solve that. Pause, come back when you think you have the answer. All right, let me show you and talk you through how this problem is solved. Okay, so let's look. The first thing that I want to figure out is, well, I know that he can go 25 miles, I'm right over here, 25 miles on 1 gallon of gas, but he wants to go 1,400 miles. Well, I have to know how many gallons of gas that takes, because that will tell me how many tanks he needs in just a little bit. So to solve this, I did my math just like I've done before. I circled that up. 1 times this is 1,400. Then I divide by the number left over, and I got 56. So 56 is the number of gallons that he needs to make it this many miles. Okay, we can't stop there though. We don't care about how many gallons of gas he needs. We want to know how many full tanks of gas he'll have to fill up with. So now I need to take these gallons and divide it by 15, because that is a full tank. So a full tank is 15. So if I fill it up, how many times will I have to fill it up? So I would divide. And then I found that I was dividing, and then I got this 0.7, and then I had another drop, and then I could say how many times of 5 going to 50? What is that, 3 times? Well, if you look at this, I don't need any more information, okay? I'm looking here. Well, to get exactly there, it's going to be 3.73 full tanks of gas. We don't have that answer here. So if we need full tanks, we don't want this partial here, but we do know he would need that much. So we can't cut it off at 3, but we could predict that he needs about 4. All right. I know that rates and ratios are brand new and they're a little tricky to get through sometimes, but if you give it your best shot, that's all we can do, right? Hope you learned a little bit from today. I'm also going to get a little grumpy about Study Island. I want you to visit Study Island. I want you to try a few things. Go there a few times this week. See if you can get some work done. I sent a paper of your progress on Study Island home. I want to send home a much better one in the next couple of weeks. Have a great rest of your week. We're done with this page today, and I'll talk to you next video next week. Bye-bye.